Welcome to today's lesson. Today, we're talking about a broad part of mathematics called measurements. And under measurements, we'll take one small part called perimeter. So, we're going to learn about perimeter. By the end of today's lesson, you will know what perimeter is, how to find perimeter of any given object, shape, figure, or body. Listen to it again. You will know how to find perimeter of any given object, shape, figure, or body. Let's go. Now, supposing your dad wants to put lighting around your fence wall at home, how will you know what measure of wire to buy for the lighting? You would have to calculate the distance from one point of the fence wall to the other. That's what we call the perimeter, which means you have to calculate the distance around the house, which is the fence wall, from one point to the other to get the perimeter. So in essence, a perimeter is the distance around a given object. Mind you, I'll be using these words interchangeably: an object, a body, a shape, and a figure. They all mean the same thing: an object, a body, a shape, and a figure. Now, there are different types of figures. We have regular figures, and then we have irregular figures. No matter what kind it is, we can find perimeter for any of them. Let me help you define these two. A regular figure is a figure that has every side of it equal, has all sides and angles equal. An irregular figure, on the other hand, has different sizes at different parts and different angles. Two of them may be equal, but all of them will not be equal. That's an irregular figure. Now, let's put this into practice. Supposing this is your fence wall at home, and you have your house inside as this. We want to calculate the distance around the fence wall to get how much or what length of wire your daddy should buy for lighting around the fence. So, for example, this place, let's give it 20 meters. That's an example. Then this place should be 35 meters. Now, I hope you know what shape this fence wall gives us. I know you know that. So, this place will also be 20 meters, then this place 35 meters. Right. What we do here is to calculate the distance from here to here, then here to this place, then up to the point we began. Now, to get this, we begin by adding the first 20 meters, which is this one, plus the next 20 meters on the opposite side, then plus this one, 35 meters, then the last one here, 35 meters. Then we have 20 plus 20, which is 40, then 35 plus 35, which is 70. So this one gives us 40 meters plus 70 meters, which will eventually give us 110 meters. So this is the distance around our fence in the house. So daddy will need to get 110 meters of wire to be able to light up the whole fence at home. And 110 meters is the perimeter of the fence at home. Now let's try this with a plain figure, which you're all aware of. Let's take a triangle, for instance. This is a beautiful triangle. So let's say we have 15 centimeters. Note, I have changed the units this time. Then we have, let's say, 20 centimeters on this side. And then this side gives us 10 centimeters. Then to find the perimeter of this triangle, as we did for the earlier fence wall, you just calculate the distance from here to this side to that side, and this one to this side, which means we are adding 15 centimeters to 10 centimeters, then to 20 centimeters. Plus 10 centimeters, then plus 20 centimeters, which will eventually give us 15 plus 10 gives us 25, then plus 20, that will give us 45 centimeters as our perimeter. As simple as this, I know you can all do it without any problems. Remember I spoke about regular figures. Now, a regular figure is a figure with all its sides and angles equal. Let's look at this. This is an equilateral triangle. It has all its sides and angles equal. So if we have here to be 5 centimeters, here will also be 5 centimeters. Here will also be 5 centimeters. So finding the perimeter for this triangle will not be difficult at all. You just add your 5 centimeters plus 5 centimeters plus 5 centimeters. Then 5 plus 5 plus 5 give us 15 centimeters. 15, then you add your centimeters to it. Don't ever forget your units. Another regular figure is a square. So like you know, a square has all its sides and angles equal. So if I have 2 meters here, we are sure to have 2 meters here, another 2 meters here, and another 2 meters here. And finding the perimeter for this square wouldn't be difficult at all. Therefore, since you know that a regular figure has all its sides and angles equal, when you are given one side, you should know that all the other sides are of the same length. Therefore, a square with 2 centimeters on one side should have 2 centimeters on all of the other sides. Therefore, in finding the perimeter, you're supposed to add this side and 2 here, another 2 here, another 2 here to get your perimeter all over. The same way with this. When you have only 5 on one side, you should know that all the other sides have the same dimension. That's okay with regular figures. Let's move on to irregular figures. But before we do that, let's solve this one here. Let's find the perimeter for this square with one side 2 centimeters. So 2 centimeters plus this side 2 centimeters plus this side 2 centimeters, then plus this side, it's also 2 centimeters, which will give us 2 plus 2 plus 2 plus another 2 here. That will be 8 centimeters. Is that right? Sure it is. Remember, your unit must always be added to your answer. Now to irregular figures. I'm going to put irregular figures into 2 separate groups. The first group is this. Now, these are my first set of irregular figures. Notice something about all these figures. Think about what is common among them, or what are the differences among them. Let me tell you. Now, an isosceles triangle, it has 2 opposite sides of equal length. So this side, the same as this side. If we have 6 centimeters here, we are sure to have 6 centimeters here. But this side will be different. This is an isosceles triangle. It has 2 sides of equal length and 2 angles equal. Now, a rectangle. Hope you all know a rectangle. Opposite sides of a rectangle are of equal length. So this side is equal to this side, and this side here also equals to this side. So if I have 7 meters here, I'm sure to have 7 meters here. And if I have 4 meters here, this side will definitely be 4 meters. Then a parallelogram. Be careful when you mention it. Now, this is just a tilted form of a rectangle. And so, just as a rectangle, two opposite sides are equal. This side and then this side are equal to each other. Now, this one here is a kite. I don't know if any of you have played with a kite before, but when I was young, we played a lot of kites. So a kite has two of these sides here facing each other of equal length, and this other two also of equal length. So if I have 11 millimeters here, I'm sure to have 11 millimeters here. Then if I have, say, 4 millimeters here, this side will also be 4 millimeters. Now, these are my first group of irregular figures. What you should have in mind is that if you have all the dimensions of any of these figures given you, that's cool. You can have your perimeter calculated with ease. But in some other cases, you may have only two sides given, 7 meters here and then 3 meters here. With what I just told you, you should know that this 7 meters should tell you that here is also of 7 meters. This 3 meters here, being opposite to this side, should tell you that this side is also 3 meters. Therefore, in calculating your perimeter for this parallelogram, I hope you got it right. It's going to be 7 meters plus the second 7 meters here, then plus the first 3 meters, then an unseen 3 meters on the other side. And so 7 plus 7 will give us 14, plus 3 will give us 17, then another 3 will give us 20. Don't forget to add your meters. Therefore, our perimeter for this parallelogram is 20 meters. And this can happen to any of these shapes here. You'll be given this side, but not this side, or this side, but not that side. You should know that the opposite sides are of equal length. Same with the isosceles triangle and then a rectangle. All right. All these are irregular figures. Whatever name you give to it, that's yours to think about. So in this case, we may have 7 meters here, and then let's say 2 meters here, then 3 meters here. Here should give us, okay, let's look at 3 meters here for this length, then 10 meters here, and then here will give us 5 meters. Once again, all the sides of this figure have been given dimensions. In some cases, you would have some of the sides without dimensions, and will be given to you as a question to solve for. So, with this figure, you can easily calculate your perimeter. 5 meters plus 7 meters plus 2 meters plus 3 meters, 3 meters here, and then 10 meters here. Now, in the case where you have a similar figure and some of the dimensions are taken out, this is what you do. For example, we have, let's say we have this is too big. So we have 4 meters here, then 2 meters here. Then for this side, we have 3 meters. Then we're given here to be 10 meters. Pay attention here. We have this side to be 4 meters. This whole length is 10 meters. We have 3 meters for this length here, and then 2 meters for the upper one here. This side is not given. That side is not given. What do we do? But we need to calculate for the perimeter. Now, this is what you do. Taking into consideration this whole length here, excuse my drawing, is this side in addition to this side. So for example, if you are to cut this shape into 2 on this side, you will have this side here equaling to this part. And so here being 2 meters will definitely mean that the rest of this side is also 4 meters. So we have 2 meters and this side 4 meters, which will give us the whole of this top. So 2 meters here, then this side 4 meters here. So 2 plus 4 will give us 6 meters for the top here. Now for this side, just as we did for the top here, let's assume that the shape is divided into 2 equal parts, okay, again on this side. And we have this length here to be 3 meters. But we have the whole of this place to be 10 meters, which means that here is 3 meters, and all of this place being 10 meters, let's take out the 3 meters from the 10 meters here. Then the rest will be equal to the remaining side here. So here we will have 10 meters, take away the 3 meters on this side, which will give us 7 meters. So finally, this is how our shape is going to look like. We're going to have 6 meters here, 10 meters on this side, 4 meters here, then 3 meters here, and then 2 meters there, then finally 7 meters here. Now you are set to go. You can easily calculate your perimeter with much ease. So we have 7 plus 6 up here, then plus our 10 meters, then plus 4 meters, plus 3 meters, plus our last 2 meters. And that will give us 7 plus 6 is 13, plus 10, 23, plus 4, that gives us 27, then plus 3, that gives us 30 meters, and then plus 2, 32 meters for our perimeter. Now, you will be meeting a lot of these in the test to come. Because you are growing, you should start thinking on these type of things, not getting everything provided for you. So if you didn't get this one, watch this video over again and again and again and again until you get it. Let it be a part of you. Then you can do whatever that comes your way in terms of perimeter. So, in conclusion, a perimeter is the distance around an object, a body, a figure, or a shape. Don't forget that. And there are 2 main groups of shapes. You have the regular shapes and the irregular shapes. And I told you that finding the perimeter for a regular shape, very simple. You are given one side or one dimension, you replicate it for all the other sides. And just add it according to the number of sides of the shape. For irregular objects, you will need to find the dimension for every other part of the shape. Add all together, then you have your perimeter. See you again. Remember, go to files and check perimeter part 2. Click on that file, and then there are some more exercises there for you to do. Master it, then you become a master of perimeter. See you.